In this video, I'm going to discuss the remainder and the factor theorems. And I'm going to do several examples of kind of their application and what that looks like. So the first thing that we're going to look at is the remainder theorem. So it says, if a polynomial, we have our f of x, and so we'll have several examples of nice functions that are polynomials. And if that's going to be divided by x minus k, so we're saying if it's divided by a nice binomial, there's no coefficient out here for our x, it's just x, and then plus or minus some constant, then we can tell that the remainder is going to be r for remainder equals f of k, which just means if we evaluate the function at k, we can know if there's going to be a remainder or not. Okay, so let's think about the special case where maybe when we evaluate the function and it's 0, right? So that means that the remainder is 0, and if the remainder is 0, it means it's a factor of the polynomial function. So the factor theorem then is kind of a special case of the remainder theorem. It kind of leads right from it, and it says a polynomial function f of x has a factor x minus k if and only if when we evaluate the function at k we get 0. So maybe let's take a look at what an example might look like for this. So in this first example we have the function f of x equals, we have x to the fourth minus 11x squared minus 18x minus 8. Well, based on kind of the things we just talked about, the factor theorem and the remainder theorem, we can evaluate a function at some constant and see what the remainder is going to be. So let's think about just using x minus 2. Let's think about dividing this polynomial by x minus 2. So as x minus k is our form for our binomial that we're going to divide by, so it looks like our value of k is going to be 2. So we can tell if there's going to be a remainder now by finding f of 2. Okay, so let's go ahead and plug 2 into all these places we have x. So 2 to the power of 4 minus 11 times 2 squared minus 18 times 2 minus 8. And now it's just a matter of simplifying this. So 2 to the fourth is 16, 2 squared is 4, and 11 times 4 is 44, minus 18 times 2 is 36, minus 8. So when we do all of this, it'll be, what, 16 minus 44 is negative 28, minus 36 minus 8. So then what, negative 64 minus 8. I mean, we're definitely not heading down, right, to the 0 path. So we can say that x minus 2, when we divide this polynomial by x minus 2, there's going to be a remainder. So it's not going to divide nicely. And our remainder is going to be this negative 72 business. So x minus 2, not a factor, right? Maybe let's try another number. Maybe something smaller so we don't get to those giant numbers. Let's maybe try f of 1. So this is x minus 1. So my k value is 1. So I'm going to evaluate the function right there at f of 1. So 1 to the power of 4 minus 11 times 1 squared minus 18 times 1 minus 18, right? Doesn't really look much better here. So 1 minus 11 minus 18 minus 8. So 1 minus 11 is negative 10, minus 18 is negative 28, minus 8 more is negative 36. So x minus 1, not a factor because we had this remainder here. Okay, well maybe let's just try a couple more just to see what happens. So let's maybe instead of x minus 2 and x minus 1, maybe we try an x plus 1, which means that this is really x minus a negative 1. So our value of k is negative 1. So we will evaluate the function at negative 1. Well, negative 1 to the fourth minus 11 times negative 1 squared minus 18 times negative 1 minus 8. So negative 1 to the fourth is 1. Negative 1 squared is 1, so minus 11. The negatives here, the negative 18 and the negative 1 makes a plus 18 minus 8. This looks a little more promising. So 1 minus 11 is negative 10. Negative 10 plus 18 is 8. And 8 minus 8 is 0. Hey! So I know that x plus 1 is a factor of my polynomial function up here. Okay, maybe we can find one more. We tried positive 1 and positive 2. Maybe let's evaluate it at negative 2 now. Okay, so what that would look like if k is negative 2, then it'd be in this form. So we're seeing if our polynomial function is divisible by x plus 2. Okay, well let's plug these things in and see what we get. So negative 2 to the power 4 minus 11 times negative 2 squared minus 18 times negative 2 minus 8. So negative 2 to the power 4 is 16. And then like we saw before, this negative 2 squared is 4, so minus 44. But now again we have the two negatives that make a plus 36, and then minus 8. Okay, so 16 minus 44 is negative 28 again. But negative 28 plus 36 this time is positive 8. Positive 8 minus 8 is 0. So hey, we found another factor of this polynomial function that we started with. So I know that this is divisible by both, which means I can divide it, by x plus 1 and x plus 2. So both those rascals are going to be factors because we used our remainder theorem, and when we plugged in our k value, we got 0 for the remainder in each case, which then the remainder theorem tells us that if we get 0 for the remainder, then it's a factor. So I've rewritten my polynomial function here, and I know that my factors are at least x plus 1 and x plus 2. So maybe let's take a second and actually divide these out and see what it looks like. Well, since this is a nice x minus k form for both of these, I can use synthetic division. So my value for k here is negative 1. My value for k here is negative 2, for those reasons before, because it's x minus a negative 1, because the minus and negative makes this plus right there. So that works in both cases. So we'll put this negative 1 out front here when we start our synthetic division. And then we need to get our coefficients from up here. So our first coefficient is a 1, but there's no x cubed term, so I need to put that placeholder in as a 0. And then the next one is negative 11. And it looks like negative 18 and negative 8. Okay, well let's go ahead and use synthetic division. So we bring this first guy down, so 1. And negative 1 times 1 is negative 1. And I add them up, so negative 1. Negative 1 times negative 1 is positive 1, so negative 10. Negative 1 times negative 10 is positive 10. When I add them, negative 8. And then negative 1 times negative 8 is going to be positive 8, which makes this remainder here 0, which we knew it was going to be. Okay, so we can rewrite this now as 1 power less, so x cubed minus x squared minus 10x minus 8. So here's what this polynomial function looks like after we take this and divide it by my x plus 1. Well, let's go ahead and take this guy now and put him up here and divide by the x plus 2. So I can take my polynomials again here, right here. So coefficients 1, negative 1. So I'll do 1, negative 1, negative 10, and negative 8. And that's going to be divided this time by my k value was negative 2. Okay. So bring down the first one is 1. Negative 2 times 1 is negative 2. Add these, we get negative 3. Negative 2 times negative 3 is positive 6. So when I add these, I get negative 4. And then negative 2 and negative 4 makes positive 8, which again gives 0 when we add those up right there. Well, that's nice. So take 1 from the power, which was cubed. So x squared minus 3x minus 4. And so we just now divided that by the x plus 2 here. So we've divided by x plus 1 and x plus 2. And now that it's down to this nice quadratic, I'm trying to see if I can factor this more. So what two numbers multiply to make negative 4 that add to make negative 3? Well, that should be pretty nice. So it should factor just like that. So I took some things out that I knew would factor nicely, and then I kind of got it down to this quadratic, and then I was able to factor it using my quadratic techniques. So let's look at now all the things that I just factored out of here. So I factored out an x plus 1 originally, and then an x plus 2 we just got done doing our synthetic. And then when we factored it, we have these. So it looks like we have these 4 factors that all went together. So my function f of x which equaled x to the fourth minus 11x squared minus 18x minus 8, can also be written in factored form. So we have an x plus 1 and an x plus 1. So we say its multiplicity is 2, because there's 2 of them squared there. And then x plus 2 and x minus 4. So we could kind of look at this polynomial function as being factored with these factors. In this next example, we have the question, if f of x equals this polynomial, then circle all the factors of f of x. So we've got some choices down here, 4 factors, and we want to know what will divide this nicely. Well, we can use the idea of the remainder theorem, and we can evaluate the function at my k value in each case, and if it comes out to be 0, then it's a factor, but if it doesn't come out to be 0, it's not a factor. So let's get the k value in each instance. So we know my binomial needs to be x minus k. So here's a minus, so I know automatically this one k value is 1. And here's a minus, so this k value is 3, because I just straight from this form. But these are pluses here, so I know it's x minus a negative 1, that's what gave me that plus. And x minus a negative 3, and that's what gave me that plus. So in this case, my k value should be negative 1. And here my k value should be negative 3. So it looks like all I really need to do is evaluate this function at these 4 spots, and then I'll know which ones are factors and which ones are not factors. So we'll start with negative 1, so f of negative 1, negative 1 to the 4th, minus 6 times negative 1 squared, minus 8 times negative 1 minus 3. Okie dokie, well, negative 1 to the 4th is 1, negative 1 squared is 1, so minus 6, 2 negatives make a positive, and minus 3. So 1 minus 6 is negative 5, negative 5 plus 8 is 3, 3 minus 3 is 0. Hey! So we found a factor, so x plus 1 is a factor. So to try for x minus 1, we need to put k equals 1, so we're going to find f of 1. So 1 to the 4th minus 6 1 squared minus 8 times 1 minus 3. So 1 to the 4th is 1 minus our 6 again. This time it's minus 8 minus 3. Well, too many negative signs here, huh? So 1 minus 6 is negative 5. Minus 8 is negative 13. Negative 16. So no dice on that one. So x minus 1 will not be a factor. Okay, so let's try our third value, k equals negative 3. So f of negative 3, when we plug in negative 3, it'll be negative 3 to the 4th, minus 6 times negative 3 squared, minus 8 times negative 3, and then minus 3. Well, negative 3 to the 4th is 81. Negative 3 squared is 9, so minus 54, plus 24 minus 3. So here we go. 81 minus 54 should be 27. 27 plus 24 should be 51. Minus 3 is 48. Well, 48 is not 0, so that guy's not going to work either. Well, let's try our last one, see if something good might happen. So we're going to evaluate it at k equals 3. So we're going to do f of positive 3 this time. So positive 3 to the power 4 minus 6, positive 3 squared, minus 8 times positive 3 minus 3. Just evaluating this thing, right? You can use your calculator just as easily as you could use anything else. So we said that's 54 minus 24 minus 3. Well, 81 minus 54 we said was 27. Minus 24 is 3. Hey, 3 minus 3 is 0. Yeah, that works. So we know we have another factor. So looking back at the original function now, we have f of x was x to the 4th minus 6x squared minus 8x minus 3. And we wanted to know which of these were factors, so we used our remainder theorem and the idea of our factor theorem as well, where if you evaluated the function at that k value and it came out to be 0, like the first one and the last one, then we know they're factors. But in the middle, they didn't come out to be 0, so they're going to have remainders. And we didn't really care about the remainders so much in this case. We just wanted to know which of these were factors of our polynomial function.